A United States defense standard, often called a military standard, MIL-STD, MilSpec, or MilSpecs, is used to help achieve standardization objectives by the U.S. Department of Defense. Standardization is beneficial in achieving interoperability, ensuring products meet certain requirements, commonality, reliability, total cost of ownership, compatibility with logistics systems, and similar defense-related objectives. Defense standards are also used by other non-defense government organizations, technical organizations, and industry. This article discusses definitions, history, and usage of defense standards. Related documents, such as defense handbooks and defense specifications, are also addressed. Definition of document types. Although the official definitions differentiate between several types of documents, all of these documents go by the general rubric of military standard, including defense specifications, handbooks, and standards. Strictly speaking, these documents serve different purposes. According to the Government Accountability Office, military specifications describe the physical and/or operational characteristics of a product, while military standards detail the processes and materials to be used to make the product. Military handbooks, on the other hand, are primarily sources of compiled information and/or guidance. The GAO acknowledges, however, that the terms are often used interchangeably. Official definitions are provided by DOD 4120.24 Defense Standardization Program Policies and Procedures, March 2000, U.S.D. For purposes of this article, defense standards will include standards, specifications, and handbooks. Formats. The DOD has standards about the format of standards. MIL-STD 961E, Defense and Program Unique Specifications Format and Content, 2 April 2008, Department of Defense. MIL-STD 962D, Defense Standards Format and Content, 2 April 2008, Department of Defense. MIL-STD 967, Defense Handbooks Format and Content, 2 April 2008, Department of Defense. Origins and evolution. Defense standards evolved from the need to ensure proper performance, maintainability and reparability, and logistical usefulness of military equipment. The latter two goals favor certain general concepts, such as interchangeability, standardization, cataloging, communications, and training. In the late 18th century and throughout the 19th, the American and French militaries were early adopters and long-time developmental sponsors and advocates of interchangeability and standardization. By World War II, virtually all national militaries and transnational alliances of the same were busy standardizing and cataloging. The U.S. and cataloging system and the British defense standards provide examples. For example, due to differences in dimensional tolerances, in World War II American screws, bolts, and nuts did not fit British equipment properly and were not fully interchangeable. Defense standards provide many benefits, such as minimizing the number of types of ammunition, ensuring compatibility of tools, and ensuring quality during production of military equipment. This results, for example, in ammunition and food cases that can be opened without tools, vehicle subsystems that can be quickly swapped into the place of damaged ones, and small arms and artillery that are less likely to find themselves with an excess of ammunition that does not fit and a lack of ammo that does. However, the proliferation of standards also has some drawbacks. The main one is that they impose what is functionally equivalent to a regulatory burden upon the defense supply chain, both within the military and across its civilian suppliers. Almost nothing can be done according to sound case-by-case judgment management, and almost everything requires constant, extensive study of the rules and verification that they are being followed. 280. Workflows frequently pause for reasons that are sometimes essentially trivial, and unit costs rise. In the U.S. during the 1980s and early 1990s, it was argued that the large number of standards, nearly 30,000 by 1990, imposed unnecessary restrictions, increased cost to contractors, and impeded the incorporation of the latest technology. Responding to increasing criticism, Secretary of Defense William Perry issued a memorandum in 1994 that prohibited the use of most defense standards without a waiver. This has become known as the Perry Memo. Many defense standards were cancelled. In the place, the DoD encouraged the use of industry standards, such as ISO 9000 series for quality assurance, SAE standards such as the EARS and AMS series, and others. Weapons systems were required to use performance specifications that described the desired features and performance of the weapon, as opposed to how those goals would be reached. In 2005, the DoD issued a new memorandum which eliminated the requirement to obtain a waiver in order to use defense standards. The 2005 memo did not reinstate any cancelled defense standards. According to a 2003 issue of Gateway, published by the Human Systems Information Analysis Center, the number of defense standards and specifications have been reduced from 45,500 to 28,300. However, other sources noted that the number of standards just before the Perry Memorandum was issued was less than 30,000, and that thousands have been cancelled since then. This may be due to differences in what is counted as a military standard. Another potential drawback of thorough standardization is a threat analogous to monoculture or a ship without bulkhead compartmentalization. If an enemy discovers a drawback in a standardized system, the system's uniformity leaves it vulnerable to complete incapacitation via what might otherwise have been a limited compromise. Also, if standardization promotes use by allies, it may also ease an enemy's task of using material that is lost as a prize of war. However, this threat is somewhat academic, as even poorly standardized material presents a likelihood of supplying an enemy if overrun. Non-exhaustive list of documents. Cataloging Handbook H2. Definitions for NATO stock number, federal supply groups and federal supply classes. Cataloging Handbook H4. A handbook containing vendor cage code details. Cataloging Handbook H6. Item name directory for the NATO codification system. Cataloging Handbook H8. Another handbook containing vendor cage code details. MIL-SPEC pertains to the analysis of AC and DC loads on an aircraft. MIL-STD 105 Sampling procedures and tables for inspection by attributes. MIL-STD 167 Mechanical vibration of shipboard equipment. MIL-STD 188 A series related to telecommunications. MIL-STD 196 A specification of the Joint Electronics Type Designation System. MIL-STD 202 Test methods for electronic and electrical parts. MIL-STD 461 Requirements for the control of electromagnetic interference characteristics of subsystems and equipment. MIL-STD 498 On software development and documentation. MIL-STD 499 On engineering management. MIL-STD 806 Graphical symbols for logic diagrams, originally a USAF standard. MIL-STD 810 Test methods for determining the environmental effects on equipment. MIL-HDBK 881 Work breakdown structures for defense material items. MIL-STD 882, Standard Practice for System Safety. MIL-STD 883, Test Method Standard for Microcircuits. MIL-S 901, Shock Testing for Shipboard Equipment. MIL-STD 1168, a classification system for ammunition production that replaced the ammunition identification code system used during World War II. MIL-STD 1234, Sampling, Inspection, and Testing of Pyrotechnics. MIL-STD 1246C, Particle and Molecular Contamination Levels for Space Hardware. MIL-STD 13881, Logistics Support Analysis. MIL-STD 13882B, DOD Requirements for a Logistic Support Analysis Record. MIL-STD 1394, this is concerned with the construction quality of hats and is often confused with IEEE 1394. MIL-STD 1397, Input-Output Interfaces, Standard Digital Data, Navy Systems. MIL-STD 1472, Human Engineering. MIL-STD 1474, of Sound Measurement for Small Arms Standard. MIL-STD 1553, a Digital Communications Bus. MIL-STD 1589, Jovial Programming Language. MIL-STD 1750, an Instruction Set Architecture for Airborne Computers. MIL-STD 1760, Smart Weapons Interface derived from MIL-STD 1553. MIL-STD 1815, ADA Programming Language. MIL-STD 1913, Picatinny Rail, a mounting bracket on firearms. MIL-STD 2045-47001, P Connectionless Data Transfer Application Layer. MIL-STD 2196, pertains to optical fiber communications. MIL-STD 2361, pertains to digital development, acquisition, and delivery of Army administrative, training and doctrine, and technical equipment publications in SGML. MIL-STD 2525, Joint Military Symbology. MIL-STD 3011, Joint Range Extension Application Protocol. MIL-STD 6011, Tactical Data Link 1111B Message Standard. MIL-STD 6013, Army Tactical Data Link 1. MIL-STD 6016, Tactical Data Link 16 Message Standard. MIL-STD 6017, Variable Message Format. MIL-STD 6040, United States Message Text Format. MIL-DTL 13486. MIL-PRF 38534, General Specification for Hybrid Microcircuits. MIL-PRF 38535, General Specification for Integrated Circuits Manufacturing.